So I have an infinite series here, the sum from n equals 0 to infinity of negative 1 to the n power times x to the 6n over 2n, the whole 2n factorial. And my goal in this video is to evaluate this power series when x is equal to the cube root of pi over 2. And I encourage you to pause this video and give it a go on your own. And I will give you a hint. The key to this is to figure out, well, what function is this the power series for, and then use that function to evaluate this. And there's another clue here, is that, hey, this is kind of a mysterious or suspicious looking number here, pi over 2, that looks like something I would use a trig function to evaluate. That might be a little bit more straightforward. So I'll let you have a go at it. So I'm assuming you have tried, so let's try to work through this together. And any of these types of problems, I like to at least expand out this power series so I get a better sense of what it's like. So this right over here, if I were to expand it out, this is going to be equal to, when n is 0, this is 1. Actually, all of these are 1, so it's just going to be 1. When n is 1, it's going to be negative 1 x to the 6th over 2 factorial. When n is 2, it's going to be positive. Negative 1 squared is positive 1 times x to the 12th over 4 factorial. And then let's just do one more. When x is equal to 3, it's going to be negative x to the 18th over 6 factorial. You just keep going on and on forever. Now, offhand, I don't know a function, especially a trigonometric function, because that was kind of our clue here. This pi over 2 makes me feel like this might be a trigonometric function right over here. Nothing jumps out at me offhand, but this does look suspiciously familiar. This looks awfully close to the power series or the Maclaurin series for cosine of x, which we have seen multiple times. Let's just remind ourselves what that is. And if this doesn't look familiar, the previous video where I do the Maclaurin series for cosine of x goes into detail on how I get this. The Maclaurin series for cosine of x is equal to, so I'll just write a few terms. So I'll write approximately equal to 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial minus x to the 6th over 6 factorial. And just like that, you're probably seeing the similarities. Well, the first term's the same, the sign negative, positive, negative, positive, negative, positive, negative, positive, 2 factorial, 4 factorial, 6 factorial. The difference is the powers, the exponents on the x's. This is x squared, this is x to the 6th, this is x to the 4th, that's x to the 12th. This is x to the 6th, that's x to the 18th. Well, I guess something for you to think about is, well, how can we replace x with something here? Because anything that I change, if I take cosine of, if I change x to, I don't know, a plus b, everywhere we see an x, you would replace it with an a plus b. Can we put a power of x here so that these things end up like that? Well, this x to the 6th is the same thing. X to the 6th is the same thing as x to the 3rd squared. That's x to the 3rd squared. This right over here, x to the 12th, is the same thing as x to the 3rd to the 4th power. This right over here is the same thing as x to the 3rd to the 6th power. So if we could replace each of these x's with x to the 3rds, we will get this power series up here. Well, how do we do that? Well, we would just say, well, it's the cosine of x to the 3rd. And actually, let me do that in a different color. So the cosine, and that's not a different color. So the cosine of x to the 3rd is going to be equal to, and once again, everywhere we see an x, we replace it with x to the 3rd. So it's 1 minus, and actually I'm just going to put in parentheses squared, 2 factorial. Actually, I want to do that in the green. Let me do all of this in the green. All right, so it's going to be equal to 1 minus parentheses squared over 2 factorial plus parentheses to the 4th power over 4 factorial minus parentheses to the 6th power over 6 factorial. And now let me change back to that mauve color. And since I'm taking the cosine of x to the 3rd, well, this is going to be x to the 3rd squared. This is going to be x to the 3rd to the 4th power. This is going to be x to the 3rd to the 6th power, which is exactly what I have right over here. So this right over here is the power series for cosine of x to the 3rd. So evaluating this when x is equal to the cube root of pi over 2 is the same thing as evaluating this when x is equal to the cube root of pi over 2. Let me write that down because this is interesting. So I'll just rewrite it from n equals 0 to infinity of -1 to the n, x to the 6th n over 2n factorial. This is equal to, this is the power series representation of cosine of x to the 3rd power. So if you want to evaluate this when x is a cube root of pi over 2, we just have to evaluate this when x is a cube root of pi over 2. And this does suspiciously work out nicely, because if you take the cube of the cube root, well, good things happen. So the cosine of the cube root of pi over 2 to the 3rd power, well, that's just the same thing as cosine of pi over 2, which, of course, is equal to 0. And we are done.